Good morning, students. I welcome you back again to this class. Yeah, we have been dealing with the gradients and the equations of straight lines. And I hope today we shall conclude this topic so that from the next class we shall begin another topic. In the last class we were dealing with perpendicular lines. The last class we were dealing with perpendicular lines, where we said that these are lines that bisect at 90 degrees. These are lines that bisect at 90 degrees, and the lines which bisect at 90 degrees, the product of their gradient is -1. The product of their gradient is -9. The product of the gradient is -9. So we said when you're given a pair of equations, you can state their gradient. You can state their gradients because the equation should be in the form of y is equals to mx plus c. Now you will state their gradients and multiply them. When you multiply them and the result gives you -1, it means they are perpendicular lines. Again, we also talked about how to find an equation of a straight line from a perpendicular line given and given its point. For example, we said find an equation which is perpendicular to y is equals to -1/2 x plus 4 and passes through the point 3, 4. We know that our M1 is from the line that is being given there. Our M1 is from the line that is given there, which is -1/2. So we find our M2. Our M2 comes from M1 times M2 gives us -1. So -1/2 times -2 gives us -1. Now -1/2 M2 will give us -1. Then we multiply both sides by 2, so that -M2 is equals to -2. Then we divide by negative, so our M2 is 2. Then you also have the point through which the line passes, through which the equation that passes. Then we said this is our x and this is our y. Equation is y is equals to mx plus c. Now we have y, which is 4, we have m, which is 2, we have x, which is 3, plus c. So we find the c, that is going to be 4 minus 6 is equal to c. Now our c is equals to -2. Our equation is y is equals to mx plus c. Now we substitute m and c because we have them. So you're going to have y is equals to 2x minus 2. And this is the equation that you've been told to find, which is perpendicular to this line, and it passes through the point. Now, the most important thing here is how to find the M2. Now, I never talked about the reciprocal of line 1. If you have the gradient of line 1, then find the reciprocal of that gradient of line 1. You'll find that it will give you +2, because if this is -1/2, the reciprocal of this will be 2. Now, there is another way of finding it. That is what I've been using, and that's what I taught last time when we were dealing with these perpendicular lines. And I just wanted to remind you on what we were dealing with in the last class. Today, I want majorly to talk about the parallel lines. I want to take you through parallel lines. I want to take you through parallel lines. That was just a recap on what we did the previous class, and I had left some questions that you as a student who is at home to work out and see if you are getting the answers. Today I want us to look at the parallel lines. Parallel lines under the gradients and equations of straight lines. Parallel lines under gradients and equations of straight lines. Parallel lines are fixed. They are lines which have a fixed distance apart. These are lines. They are lines. They are lines with a fixed distance, apart. They are lines with a fixed distance apart, and they are lines which will never meet, no matter how long you will extend them. No matter how long you will extend them, they will never meet. So you're saying these are lines. They are lines which with a fixed distance, apart, right? And they are lines which will never meet, no matter how long you will extend them. The parallel lines have the same gradient. The parallel lines have the same gradient. Now we say, therefore, the M1 is equal to the M2. The M1 is equal to the M2. M1, of course, we said M1 is the gradient of line 1. And M2 is also the gradient, you need to know this as a student, is the gradient of line 2. So this is the tool that we use when it comes to the parallel lines. You need to know as a student that the lines will never meet even if you extend them. No matter how long you're going to extend these lines, they will never meet. And these lines, they have a fixed distance apart, right? They have a fixed distance apart. For example, if we say these are the lines, this is line 1 and this is line 2. Now you realize they have a fixed distance apart. This distance here is fixed, right? And then they are moving to that direction. They are moving in the same direction, but they will not meet. You extend it, whatever distance you're going to extend, how long you're going to extend it, the lines are not going to meet. They will never meet. Now, they have the same gradient. For them to be parallel, for them to be referred as parallel lines, they must have the gradient. Must have the same gradient. That's why we are saying M1 should be equal to the M2. M1 should be equal to the M2. Remember, in perpendicular lines, we said the M1 times M2 is equal to -1. but in the parallel lines, their gradients are the same. And we say that M1 is equal to the M2. Now, you'll be asked to find or determine if the pair of equations that you have been given are parallel lines. And how do you do that? For example, if we say determine if the pair of equations given below are parallel lines. They are parallel lines. Determine if the pair of equations given below are parallel lines. Roman 1, we have y is equal to 2x plus 4. And Roman 1 still, we have 2x minus 4 minus 3, for instance. Now, in this case, it's easy. We said ensure that the equations are in the form of y is equal to mx plus c, so that it is easy for you to highlight the gradients. It is easy for you to highlight the gradients. You realize that the two equations that are given in pair form, they are written in the form of y is equal to mx plus c. Now, you can state their gradients, because say m1 is 2 and m2 is 2, meaning the m1 is equal to the m2. Therefore, they are parallel. They are parallel lines. They are parallel lines. Roman 2, we have y minus x plus 4 is equal to 0. Then you also have 2y plus 4x plus 6 is equal to 0. Now, these equations, they are not in the form of y is equal to mx plus c. Then we said, for us to determine whether they are parallel lines, we should be in a position to state their gradients. You have to state the gradient first. But you cannot state the gradient while these equations are not written in the form of y is equal to mx plus c. So we start by writing that equations in the form of y is equal to mx plus c. So we start with the first one, where we say we take negative x and plus 4 the other side. We'll have y is equal to x minus 4. And then in the second one, we have 2y plus 4x plus 6 is equal to 0. So it is 2y is equal to minus 4x minus 6. Then we divide both sides by 2, by 2, by 2. So that we're going to have y is equal to minus 2x minus 3. Now, the two equations, we have written them in the form of y is equal to mx plus c. The two equations, we've written them in the form of y is equal to mx plus c. Now, what is left is now to state the gradient and check if they have the same gradient, because in parallel lines, we said for them to be parallel lines, they must have the same gradient. Now, we're going to say line 1 is y is equal to x minus 4, and line 2 is y is equal to negative 2x minus 3. So our m1 from the equation, we have it's equals to 1, and our m2 is equals to what? Negative 2. You realize that they are not the same gradient. Now we say m1 is not equal to m2. So we say they are not perpendicular. They are not parallel. They are not parallel lines. They are not parallel lines. Why? Because their gradients are not the same. Their gradients are not the same. Lastly, in Roman 3, we say we have y is equal to 4 minus x. And then we also have y is equal to minus x plus 6. Now, the first equation there has not been written in the form of y is equals to mx plus c, so we reorganize it, right? So you're going to say y is equals to negative x plus 4. Now, the negative has not changed. We have only changed the position. And I remind you on what he said last time, that we can only change the sign once it crosses the equal sign. But if it has not changed the equal sign, then it remains to be the same. Now, the next is y is equals to negative x plus 6. Now, our m1 is equals to negative 1, and our m2 is equals to negative 1. So, m1 is equals to m2, meaning they are parallel lines because they have the same gradient. Now, it is very important for you as a student to know how to write equations in the form of y is equals to mx plus c. By knowing this, you will be in a position to state the gradient, because for us to determine if the pair of equations are parallel, it means you need to state the gradient and check if those gradients are the same, because in parallel lines, they must have the same gradient. They must have the same gradient. And if they don't have the same gradient, it means they are not parallel lines. So parallel lines have the same gradient. Now, question 2 on the same. Question 2 on the same. Question 2 on the same. You'll be asked to find the equation. You will be asked to find the equation of straight lines. The equation of straight line using this concept of parallel lines. Using this concept of parallel lines. How is that possible? How are we going to do it? Let's go to the question 2. Write this. Find an equation of a straight line. Find an equation of a straight line that is parallel to y is equals to 5x plus 4 and passes through the point and passes through the point and passes through the point 1 and 2 and passes through the point 1 and 2. Now, finding equations of straight lines, we said there are two ways. There are two ways of finding the equations of straight lines. If I remind you what we did in our first class under the gradients and the equation of straight line, we said if you have 2 points that lies within the straight line, then we start by finding the gradient. And given a point and a gradient, if you have the point and a gradient, you can go ahead and find the equation using our equation y is equals to mx plus c. Now, in finding the equation of a straight line that is parallel to, it means the parallel lines, the gradient of line 1 and the gradient of line 2, there must be the same. Now, in the equation that you're finding, so let's take that equation to be in line 2. We are finding line 2 because line 1 is given, meaning we need to have its gradient, which is not given. We need to find its gradient, that is gradient 2, like m2, because it's not given. And how do we get it? We get it from the equation that is given, which is y is equals to 5x plus 4. We find the m2 from this equation because he said they are parallel lines. If they are parallel, then that means m1 and m2 are the same. So if we have m1, it means we have the m2 because they have the same gradients. Meaning, when we say y is equals to 5x plus 4, our m1 is the coefficient of x in the line that is provided. So our gradient here is 5. If the gradient is 5, of line 1, and we know that they are parallel lines, meaning if they are parallel lines, and then we say m1 is equals to m2, so m2 is also gradient 5. It is 5. Now, that equation that we are finding passes through this point. It passes through point 1 and 2. And I said points are written in coordinate form, starting with the value of x followed by the value of y. Remember, you're finding the equation in the form of y is equals to mx plus c is equals to mx plus c. Now we substitute because we have these values apart from c, which is the y-intercept is not given. So that is what we are finding. Now we have y, which is what? We have y, which is 2. We have m, that is 5. We multiply by x, which is 1, plus c. Now 2 is equals to 5 plus c. Now bring this 5 the other side. It's 2 minus 5 is equal to c. Our c is negative 3. Now equation is y is equals to mx plus c. Now we don't substitute values of y and x because these are variables which change. Or the only constants we have is constant m and constant c that we are going to insert because we have their values here. We said c is negative 3 and m is 5. So we're going to say y is equal to 5x minus 3. And this is the equation that you've been asked to find that is parallel to this line. We said they have the same gradient. In line 1, the gradient is 5. And in line 2, the gradient is 5. But their constants are different. This is constant 5, constant 4, and that is the y-intercept there is negative 3. Alternatively, when you have the m2, which is 5, and you have the point, which is 2 and 1, we say let another point be x and y. Remember, points are written in coordinate form. So let's refer this as x1 and y. This is x2, y2. And this is our x1 and y1. Remember how we find the gradient. So we use that formula of finding gradient. We say gradient is change in the y-axis over change in the x-axis, which is y2 minus y1 over x2 minus x1. You can also use y1 minus y2 over x1 minus x2. All of those will give you the same answer. Now let's substitute that. y2, according to what we have there, is y, and minus, we have y1, which is 2, divided by x2, which is x minus 1, will give us the gradient, which is 5. The gradient is already provided. So we are equating to the gradient because it's the gradient that we are finding. Now, we cross multiply that, 1 into y minus 2 into 5 into x minus 1. Now, we open the bracket, you're going to have y minus 2 is equals to 5x minus 5. Now, this, we take negative 2 to the other side so that our equation can be in the form of y is equals to mx plus c. So, y is equals to 5x minus 5 plus 2. Give us y is equals to 5x minus 3. Now, this is another method of finding an equation of a straight line once you have the gradient and the point. Remember, where we get the gradient from is from this equation. And they said the equation that we are supposed to find is parallel. Once we talk about parallel lines, then it has to occur in your mind that parallel lines have the same gradients. And if they have the same gradient, now we can state our first gradient because the equation is given. And the equation is written in the form of y is equals to mx plus c. Now our gradient 1 is 5. So our gradient 2 becomes positive 5 because of the fact that they are parallel lines which having the same gradient. And then you proceed on how to find the equation from given a point and the gradient. And in this case, I've given you two methods of finding the equation of straight lines once you have the gradient and you have the point. We proceed with question 3. Let's proceed with question 3 on the same. Let's proceed with question 3 on the same. We say question 3 is find the equation of straight line that is parallel to y is equal to a half x plus 4 and passes through the point 6,1 and passes through the point 6,1. Now, the point here is the fact that it is parallel to. Now, when it's parallel to, it means M1 should be equal to the M2. That is the tool we say we use in parallel lines. That M1 is equal to the M2. M1 is equal to the M2. Now, we're going to have our equation y is equal to a half x plus 4. And then we state our first gradient. Gradient of line 1 is going to be a half. Gradient of line 1, which is a half, meaning our M2 is also a half. Because the fact that the line that you're finding is parallel to this line given. And if it's parallel, we said that they have the same gradients. They have the same gradients. Now, we have M2, which is a half. M2 is the gradient of the line that you've been asked to find. And we have the point through which that line passes. It passes through 6 and 1. So now, let's find the equation. So we let another point being x and y. Let's let another point being x and y. Remember, this is our x1 and y1. This is our x2 and y2. Now we said the formula of finding gradients, we said gradient is change in the y-axis over change in the x-coordinate, which is y2 minus y1 over x2 minus x1. Now substituting that, because you have those values there, you substitute them in the formula, then you work out. In other words, you solve. So you're going to say our y2 is y minus our y1, which is 1, over x2. Our x2 is x minus 6 is equals to a half. Now, once you are given fractions, it is easy for you to close multiply. Once you have the fractions, it is easy for you to close multiply. And inside the brackets, again to say y is equals to y minus 1 into is equals to 1 into x minus 6. Now, we open the brackets by multiplying with all the elements inside the bracket by its coefficient. The coefficient in the first bracket is 2. So it's 2 times y, which is 2y. 2 times 1 is negative 2, is equals to x minus 6. Now take this the other side. We're going to have 2y is equals to x minus 6 plus 2. Now plus 2. Now 2y is equals to x minus 4. Then let's divide both sides by 2 by 2. So our equation is y is equals to x over 2 minus 2. This is the equation that you've been asked to find. This is the equation that you've been asked to find, that is parallel to the equation y is equals to a half x plus 4, and it passes through the point 6 and 1. We started by saying that we realized that they are parallel lines. That's why we have written M1 is equals to the M2. M1 is equals to the M2. Now we said we can state our gradient from the equation that is given. Now we can only state this gradient if the equation is written in the form of y is equals to mx plus c. And if it's not written in that form, then you are advised as a student to make sure that that equation has been written in that form. Then that is when now you can state the coefficient of x, that is the gradient. Now our gradient in this case is a half. Now we have the gradient of line 1. The fact that they are parallel lines, it means our M2 is going to be also a half. Now we have the gradient and we have the point. Now we can find the equation from the formula. Gradient is equals to change in y over change in x. Now y2 minus y1 over x2 minus x1. Then you substitute those values. So that is y1 minus 1, x2 minus 6 is equals to a half. And in this case, I cross multiplied the numerator times the denominator times the numerator, and the other side, the denominator times the numerator. And then I inserted the brackets for me so that I can work out easily without any confusion here. 2 times y, that is 2y. 2 times negative 1, that is negative 2. 1 times x, that gives us x. And then 1 times negative 6, that gives us negative 6. Now, I have to make the equation in the form of y is equals to mx plus c. That's why I started by dividing both sides by the coefficient of y, which is 2. Now, I have divided both sides by 2, by 2, by 2. Now, y is equals to x over 2 minus 4 over 2. Now, it is a half x minus 2. Now, you realize that they have the same gradient. Line 1 is y is equals to a half x plus 4. And line 2, from what we've come up with, it is a half x minus 2. These are two different equations. These are two different equations. But they have the same gradient. They have the same gradients. Now, the fact that they have the same gradient, it means they are parallel lines. It means that they are parallel lines. Parallel lines, we said, they're lines that have a fixed distance apart. They have a fixed distance apart, and the lines will not meet. They will never meet. No matter how long you can extend the lines, they will not meet. Now, at this point now, I want to leave you behind with the questions, that you can do. I want to leave behind questions that you can do. I want to leave behind questions that you can work out while you are at home there. Work out these questions. Work out these questions while you are at home. I want you to work out these questions while you are at home. This is your assignment. Yeah. Question 1. Determine if the pair of equations, because I'm winding up this class, determine if the pair of the questions given below are parallel. They are parallel lines. Roman 1, we have y is equals to negative 3x plus 4 and y plus 2y plus 6x minus 16 is equal to 0. Roman 2, because this is your assignment. This is your assignment, and I'm saying this is the last lesson that you're doing under the topic that we started, gradients and equations of straight line. Roman 2, we have y is equals to negative 2x plus 4. Then we have y is equals to a half x minus 1. Lastly, Roman 3, we have y minus x plus 4 is equal to 0. Then y is equal to x plus 6. Determine if the pair of equations given below are parallel lines. If they are parallel lines. Question 2. Question 2. Find an equation which is perpendicular, which is parallel to the line, y is equal to 2x minus 11, and passes through the point, 3 and 1, passes through the point 3 and 1. Lastly, question 3, you also find the equation with a gradient of 3 and is parallel to the line y is equal to 3x minus 6 and passes through the point 6 and 7. Now you find that there is a confusion somewhere here, so you need to understand what it means, what the question is asking, because I've given you the concept. Now the 3 are your assignment. We've tackled on how to find an equation of a straight line which is parallel to a given line. Now we said parallel lines are lines that have the same gradients. They are lines which have the same gradients. If they have the same gradient, then they are referred to be parallel lines. So finally, we said M1 is equal to the M2. This is the tool that you need to use whenever you're finding parallel lines, equations which are parallel. Make sure that the gradients of line 1 and the gradient of line 2 are the same. Now, finally, I want to tell you, my student at home, that in the gradients and equations of straight lines, you need to be in a position to know how to find the gradient. A summary on what we've been doing. Gradients, we said gradients is equal to change in y-axis over change in x-axis. Change in the y-axis over change in the x-axis, where we said m is change in y over change in x, which you said y2 minus 1 over x2 minus x1. Now this becomes the formula of finding the gradients of straight lines. So you need to be in a position to substitute this, to use this in finding the gradient of equations of straight lines. Then you need to be in a position to find equations of straight lines, Number 1 is gradient. Number 2 is equations of straight lines. And then we said there are 2 ways of finding equations of straight line. One, we said from given 2 points. From given 2 points. And number 2, from given a point and its gradient. A point and its gradient, the gradient of straight lines. Number 3, on what we've been tackling on this topic, we also talked about on how to stating the gradient and the y-intercept. And the y-intercept. And the y-intercept. How to state the gradient. We said the equations should be in the form of y is equals to mx plus c. The equations always should be written in the form of y is equals to mx plus c. Once that equation is written in that form, then we said m is the gradient and y becomes the y-intercept. And then we exploited on many questions in regards to stating or highlighting the gradient and the y-intercept. Finally, we have looked on the perpendicular lines, and parallel lines. Now, in perpendicular lines, we said the m1 times the m2 gives us -1. With a few questions that I've left behind for you, I hope that you go through the questions, and if you have any questions, you will get back to us through the channels that you're using. Otherwise, with those few questions I've left behind, I wish you a blessed and a fruitful day. Thank you.